Ichthyosaurs, the incredible prehistoric marine reptiles that inhabited the Mesozoic oceans, were an amazingly successful and diverse lineage and a significant component of the ancient marine ecosystems they lived in for millions and millions of years. Coexisting with the dinosaurs, the ichthyosaurs actually did not survive until the very end of the Cretaceous, when the famous mass extinction happened, instead dying out around 93 million years ago midway through the late Cretaceous. Indeed, it had been thought that these reptiles were on a considerable decline once the Cretaceous period started, with many of the different lineages of ichthyosaur not making it past the end of the Jurassic. However, research done in the last decade is beginning to change these ideas, with there being more evidence that various groups of ichthyosaurs actually persevered quite far into the final period of the Mesozoic. One such ichthyosaur that has changed our understanding of these animals' evolution is a species called Malawania anachronus, the ichthyosaur out of time. Malawania was actually first brought to the attention of science quite a while ago when a group of British petroleum geologists were at work in the Kurdistan region of Iraq in 1952. The fossil had already been excavated and was embedded in a flat slab of rock that had been placed in a position where it was being used as part of a dam for a small river, as well as a stepping stone that was part of a mule track crossing the water. As such, people and mules had been walking right over this fossil for some time, but fortunately it doesn't seem to have been broken in any way. Realising that this fossil was probably quite important, the geologists therefore recovered it and donated it to the Natural History Museum in London, then still part of the British Museum, in 1959. After its arrival in the UK, the history of research on this specimen then got quite complicated. Well-known ichthyosaur worker Robert Appleby, at that time based in Cardiff and really the only person researching ichthyosaurs in Britain up until the 1970s, then studied the Malawania specimen for many years, and even got close to publishing a paper on the animal, but ultimately it was rejected. Appleby unfortunately never managed to complete his study of the ichthyosaur before his death in 2004. The main issue that faced Appleby was the confusion about the reptile's true age. He was highly intrigued by the fact that the museum labelled the specimen as coming from the early Jurassic, but he noticed how archaic and more basal it looked compared to other Jurassic ichthyosaurs, and considered the possibility that it might actually have lived earlier in the late Triassic. Making contact with the geologists who had worked in the region, Appleby was advised that the specimen could not be Triassic in age and must be a Jurassic animal, since the Triassic rocks in that area were lacking in fossils. But Appleby continued to investigate the age of this organism, sending off photos of pollen grains from the slab of rock the ichthyosaur was in to an expert on palynology, the study of tiny particles such as pollen, at Cambridge. This palynologist soon informed Appleby that the pollen grains were in fact undoubtedly forms that came from the early Cretaceous, not the Jurassic as he had been repeatedly told by the geologists he was in communication with. Wanting to check if this palynological analysis had been correct, another sample was taken from the rock and examined, but all it turned up was organic residue, nothing conclusive. Abandoning the palynological approach, Appleby then started trying to find the age of the block of rock by investigating the stratigraphy of the invertebrate fossils that had been found in the area. By the late 80s, his paper on this ichthyosaur was close to being accepted for publication in the journal Paleontology, but the reviewers insisted that in order to publish he must determine the age of the fossil. Appleby, however, was preoccupied with a vast amount of other work on ichthyosaurs, and as such decided to concentrate on that before returning to this age problem. Sadly though, he died before he could ever finish his work on Malawania. Then, in 2013, a team of researchers managed to finish the study for him. This group of paleontologists was able to finally properly determine the age of this ichthyosaur by taking new samples from the rock and finding a wide range of different microfossils contained within it. These fossils demonstrated that the original palynological analysis performed decades prior had indeed been correct. This was an early Cretaceous aged ichthyosaur, despite its very archaic anatomy. These paleontologists therefore gave it the name Malawania anachronus, from Malawan, the Kurdish word for swimmer, and the Latinized Greek word anachronos, meaning out of time. The specimen itself preserves a decent amount of the reptile's anatomy. A fragmentary skull is present, comprising the bony sclerotic rings of the eyes, as well as bits of a few other skull bones, but the body is more complete. Neck and upper back vertebrae are preserved, in addition to ribs, parts of one of the shoulder girdles, and almost all of the left forefin. This might not seem like an awful lot, but it's still enough to tell a great deal about this ichthyosaur's anatomy. And what's very clear from the bones is that this reptile was certainly very archaic in its features, with the scapula and bones of the forefin, as well as others, being very characteristic of much earlier ichthyosaur lineages. As such, the 2013 paper concludes that Malawania was actually the sister taxon to the genus Ichthyosaurus itself, based on the phylogenetic analysis they ran. Since Ichthyosaurus lived in the early Jurassic, this indicates that a ghost lineage, a gap in the fossil record, of about 70 million years must exist for this branch of ichthyosaur. The important thing here is that Malawania was found to absolutely not be a member of the ichthyosaur family called Ophthalmosauridae, which before the description of this species was thought to have been the only ichthyosaur lineage to survive into the Cretaceous period. The Ophthalmosaurids seem to have undergone a radiation during the Cretaceous, and new species were actually appearing quite quickly at this time, resulting in a global colonization by this group. The difference in forefin anatomy between Cretaceous Ophthalmosaurids and their relatives in the early Jurassic also demonstrates the significant morphological evolution that these reptiles experienced as they became more and more specialized for swimming more efficiently. Meanwhile, the lineage that Malawania was a member of was remarkably conservative in terms of its anatomy and suggests that this group experienced a long period of evolutionary stasis. The paper explains how some unusual events may have affected the evolution of these particular marine reptiles, resulting in the lineage not fitting the patterns seen in the Ophthalmosaurids and remaining relatively rare in comparison. Some ideas for this very different evolutionary history have been suggested, such as perhaps the Malawania lineage was more specialized for inhabiting lagoons, and managed to survive by taking refuge in partially enclosed marine basins, such as those that appear to have been present in Iraq at this time in Earth's history. But until more information about this mysterious relict ichthyosaur group is discovered, this remains speculation. Importantly though, Malawania indicates that a lot of what we understood about the reign of the ichthyosaurs during the final period of the Mesozoic was wrong. It wasn't just a single branch, the Ophthalmosaurids, that survived the Jurassic, it was actually at least two. And if Malawania's lineage made it through, it also opens up the possibility that others did as well. But again, for now, that's complete speculation. It will be interesting to see if more members of the Malawania lineage are discovered in the future, perhaps helping to fill in the immense ghost lineage that currently exists. Malawania is certainly a fascinating animal with some incredibly significant implications for its entire order's evolution, and I think it deserves to be better known. Indeed, the remarkable work of the man who first studied this organism, as well as many other of these amazing marine reptiles, Robert Appleby, deserves more appreciation too, and I hope this video helps with that. Anyway, thank you so much for watching this video. I really hope you enjoyed it and learned something new. A big thank you to our Patreon supporters too, especially our Dinosaur tier supporters, Amanda von Nordek, Archianthus, Bella Anderson, Dhruv Shrivastava, Elijah Carrion, George Vojtek, Greg Silvernail, Just F Max, Corey Peterson, Laura Sanborn, Mike Pace, Persian Boy, Robert Thomas, Staniforth Hopkins, and Tiffany Trammell. If you would like to find out more about our world, its history, and the wonderful life that surrounds us all, please feel free to subscribe to the channel if you think we deserve it, and if you would like to see more from us.